Okay, so the end of the multiple choice. Number 51. A nuclear reaction the nuclear reaction believed to be taking place in the sun and to be responsible for the release of energy is known as, should be fusion. An element suitable for fusion is uranium, plutonium, hydrogen, all of these. Has to be tiny to be fused together, so it has to be hydrogen. Uranium and plutonium is fission, breaking apart. Those are the bigger ones. Nuclear raw materials for a fusion reaction have a total mass of 3.0067 grams. The products of the reaction may have a mass of. Okay, so if you look at these answers, the products always have to have less mass than the reactants, and the missing mass is turned into energy. So number 1 is less, number 2 is the same, number 3 is more, and number 4 is more. Has to be number 1. The product's mass has to always be less than the reactants, and the difference is converted to energy. Base your answer to 54 or 56 on the following. So it's a fusion reaction where Q represents the energy. It gives us the masses of the different nuclei. And in the first question, it says the reaction shown is primarily example of, and I already answered that, sorry, didn't realize the question, is fusion. The value of Q is nearest to what? So to find this out, you have to add the two reactants together, add the two on the product side together, and then subtract them. And when you subtract them, the difference is the Q. Okay, so on the product side, it's going to be 5.03169. And on the reactant side, 5.01, this is hard, 288, I believe. And so then you subtract them. Man, I don't know that I can do that in my head. You get choice 3. I cheated. I did it earlier. No, I didn't. I did it for real in my head here, but then I couldn't keep the numbers in my head, so I looked at my answer. In the equation given, the mass energy of the reactants as compared to the mass energy of the products has to be the same. The mass energy is the same. The mass would be different, but the total mass energy has to be the same. So the mass that gets lost as you're going to the products gets changed into energy. So the total mass energy would be the same. 57. An atom that undergoes electron capture emits. So it takes an electron in, it combines it with the proton to create a neutron, and it emits a positron. Air can be used in a nuclear reactor as, it'd probably be a coolant, I would think. It wouldn't be a good moderator. It'd have to be a coolant. Let me just check my answer to make sure I agree with myself. I do. In some reactors, the coolant also serves as the moderator, right? We had said lots of times water or heavy water are both the coolant and the moderator. Steel and concrete can be used in a nuclear reactor as the shields, the inner shield and the outer shield. Which of the following does not undergo fission? So we know uranium-235 does, we know plutonium-239 does, but uranium-238 does not. Some reactors breed plutonium by bombarding which of the following with neutrons? It's uranium-238. Fusion requires a high temperature to initiate because atomic nuclei repel each other, neutrons are not charged, gravity must be overcome, the mass must be converted into energy. It's the atomic nuclei repel each other, so you need a high temperature. Remember, temperature is a measure of the kinetic energy of the molecules, so a high temperature means they have a high kinetic energy, which means they're going so fast that the repelling forces will not slow them down before they, will not stop them before they actually get close enough together for them to fuse. And when we say close enough together, we're talking like minuscule distances here. Which of the following nuclei would be most difficult to fuse together? Hydrogen-2, carbon-12, helium-4, lithium-7. The bigger they are, the more difficult they are to fuse together. And so carbon-12 is the biggest one there. I don't think we've ever done, well, we actually, we right now we can't even do them under a controlled reaction. But even in the non-controlled, it's usually the carbons, maybe helium, but I don't think we've even attempted anything like lithium. So I would go with carbon 12. Okay? Since I have a couple of minutes and since we're finishing the nuclear unit, the one thing I didn't talk about when we were talking about fission, and it would have been in your choices for papers if you were doing the nuclear paper if we weren't shut down, was that there was some research, two scientists who thought they had developed cold fusion. And of course they announced it to the world, and it's never again been able to be reproduced. And so, there's the debate of, was it all a scam? Did the U.S. government shut them down because they didn't want energy to be cheap? But really, it's never been reproduced again, so we feel that, either it was a scam or an honest mistake. But note to self, don't announce it to the world until you know you got it right, because it's never been able to be reproduced. But a ton of countries, but Canada's not one of them, a few years ago put a lot of money together to build a research center in Europe, ITER, where they're attempting they're studying cold fusion, hoping that they can perhaps make fusion happen at a lower temperature than what we've been able to do at the moment, and therefore be able to control it. So there is still work going on with fusion, hoping that if we could somehow manage to get that to work, we wouldn't have all the radioactive waste. We wouldn't need to be mining a whole bunch of radioactive uranium. We'd be getting more energy for our buck. It would be cleaner, greener, but at the moment we don't have it. But hey, if you don't want to go into particle physics like I told you in the other video, maybe go into nuclear and work on fusion. That would be manageable and controllable.